starting off with the first problem in math concepts, we have factors of a number. It's something we have studied in our 5th standard or so. So in this question, we'll be given a number. So the input will be some number. Suppose n is equal to 12. So what are the factors of 12? It's obviously 1, 2, 3, 4, 6 and 12, right? So this must be the output. Okay. So given a number, you're supposed to deliver all the factors of the number as your output. Okay. This is the aim of the problem. Now, how can we possibly do that? It looks very simple, yes. So let me traverse first brute force method. Okay, so the flow is going to be so. I'll start off with the problem statement. I have already explained it, and the sample input output as I've shown you here. Thirdly, now let's go for the brute force approach. We'll optimize it and then we'll write the final code for this question. Okay, so this is going to be the flow I'll be following for literally all the questions that I'll be doing starting now. So yeah, we have this. As you can see, what is going to happen? You traverse, you can see that, okay, as a common 1 till 12. Okay, so I can run a for loop from 1 till 12. So whichever gives a remainder of 0, that is a factor, right? So that is the brute force approach. That is, I'm going to traverse everything, and whichever is divisible, yes, it's a factor of that number. So what I'll do is that for in some I is starting with 1, okay, and I is less than or equal to the number n I get, I plus plus, okay. So I'm going to traverse everything from 1 up till the number n, and if the number is divisible, okay, that is if the n modulus of I is equal to 0, that is the remainder is 0, then it means it's a factor. Then I will simply tell C out I, that's it. So this is going to deliver me all the factors of the number 12, right? But this is not an optimized version at all, right? So how can you optimize it basically? Just look into it. Can you find something like weird or something in common? Just think for a second, okay? We can actually see that there's a huge gap here, okay? For any number you take, obviously 1 and the number itself is going to be a factor, right? So we only have to find the numbers in between this, that is 2, 3, 4 and 6 is what is the numbers that we actually have to find out. 1 and 12 is something, it is always a prime number, let be a prime number also. 1 and the number itself is always a factor, right? So our major aim is now delivered to find only the in-between numbers. So how can I actually find the in-between numbers? Okay, since 1 and itself is already that, I can start running from 2, right? For n, some I is going to let me start from 2, and I is less than or equal to perhaps n by 2, because half of 12. Greater than 12, there's nothing. It's always like that, okay? Suppose that let's take another example. Instead of 12, let me have something like 18, okay? For another instance. So the factors are going to be 1, 2, 3, and then 6, 9, and 18. So even if you see here, you have 1 and 18, yes. And in between, you have 2 till 9. So what is this 9? It is exactly 18 by 2. Okay, what is this 6? It's exactly 12 by 2. Okay, so I can find a common thing, that is at max a number can be n by 2 only. Okay, so that's why I'm giving it as I is less than or equal to n by 2 and then I plus plus. So now same thing, this, if n mod I, again if it's divisible, if anything between 2 till n by 2, if at all it is divisible, then yes, it becomes a factor of my number, right? So C out I. That's it. So, is this the most optimized version? If you ask me, no, it's not the most optimized version. So, how can I further optimize it? That's a good question. Okay, so if you look into this, what's another common thing that you can see? I just want to know if you can see something. Fine. So, if you look into it more closely, right, you can observe that all the factors will be, you know, in the form of 2n, that is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and it's again a 6. That is, what I mean to tell is that the number of factors will always be an even number. Okay. You can ask me, how can I tell so? It is something that is proven, okay. There's nothing in me telling. The factors of any number will always be an even. like the number of factors of any number is always even, okay. Even if it's a prime number, you have 1 in itself, so it's 2, and that is again an even number, okay. So how can I make use of that? That is, I told you that the number of factors for a number is always even. So how can I make use of that thing that I got to know right now? Okay, thinking about it, how can I write this? That is 12 can be written as 1 cross 12, 2 cross 6, and then 3 cross 4, right? Similarly, 18 can be written as 1 cross 18, 2 cross 9, 3 cross 6. Okay, let's take one more. 36 can be written as 1 cross 36, 2 cross 18, and then 3 cross 12, 4 cross 9, and then 6 cross 6. Okay, so this is how a trained brain will actually write it. Okay, so how can I make use of this one? Is that if you look closely, this last one, this is all these numbers, right, from this 1, 2, 3 will always be lesser than or equal to root of n, that is 12 in our case, and this one is always going to be greater than or equal to root n. Okay, so what is root of 12? Root of 12 is something going to be 3 point something, yeah. So for that, okay, let's take this as an example. 36, root of 36 is 6, okay. Root of 36 is 6. So what I'm coming to tell you is that all these numbers, that is the left hand side of this multiplication, will always be lesser than or equal to root n, and all the numbers that is towards the right of your multiplication symbol is always going to be greater than or equal to root n. Okay, so we are going to make use of this factor and only proceed right now, okay. So rather than even n by 2, what I mean to tell is that I can reduce this factor to root n, is what I'm coming to tell you, okay. So how can I even do that? Is that, okay, I'm going to run from 1, starting from 1, because I have this 1 right here. I'm going to run from 1 up till root n only, which means it is going to reduce it manifold, okay. The number of comparisons, I'm reducing it, I plus plus, okay. So now if this n mod I, okay, becomes 0, which means it's a factor, I'm getting something of this format. I'm getting the LHS first, okay. So if the LHS is the part that is always less than or equal to root n. I'm comparing only the LHS, because what I mean to tell you is that if I get the LHS, I'll automatically get the RHS. You ask me how, 3 into 4 is what? 12. I'm trying to find out this 3, okay. I already know this 12, that is actually the input, okay. So I can find out this, right. Suppose that this is x. Suppose if I find out 3, I can automatically find out x. X is equal to what? 12 by 3. Okay, that is, I know that a cross b is my n. N is the input, okay. So b becomes what? N by a, right. I'm trying to find out this a right now. So if I find this a, I can automatically find out b, which is going to be what? N by a. Okay, so this a is what I'm trying to find out using this iteration from 1 till root n. Why this 1 till root n? As I had already told, the left hand side is always supposed to be lesser than or equal to root n only, okay. So I'm trying to find out the LHS so that I can automatically find out the number after the multiplication, that is this b. Okay, so if n mod I is 0, what can I tell? Okay, I can simply see out this I, okay. Now I'm checking if I is not equal to root n, okay. That is, you see here, this is equal to root n. So I'll get 6 cross 6. I don't want 2 6, because if I'm going to compare this, no, the output is going to be 1 2 3 4 6 6. I don't want this 2 6. Just 1 6 is enough for me. So that's why only if it is not root n, then I'll also take n by I into account. See out n by I. If you don't get this right now, it's completely fine. I'll do a code walkthrough right after this so that you will get a good idea of what I'm doing actually. Okay, so with that, yes, this is done. Okay, this is this. See out I. If I is not equal to root n, okay, this is one thing. Okay, so let's take it for 36 itself. Okay. So what I'm doing is that for 36, I'm trying to find out everything from 1, which color pen can I use? Okay. So from 1 till 6 is my A. Okay, I'm trying to find out this one. This LHS part only from 1 till 6, because automatically when I find 1 till 6, I will get the RHS of this multiplication, as I already told you this one. Okay. Fine. So now how do I find that? Right now we got the input n is 36. So I am running a for loop from 1 till what? Root 10. Root 10 is what? 6. I plus plus. So from 1 till 6 I am running it. So what will happen? 1, 2, 3, 4, 5 and 6. These are the values that I can possibly take. Okay. Right now what is my n? 36. So I am checking if n mod I is equal to 0. 36 mod 1. Yes, of course it is divisible. So in output screen, what should I print? I'll print 1. Okay, fine. Secondly, I'll go and I'm also checking if I is not equal to root 10. Okay, what is my root 10? Root 10 is 6. So if 1 equal to 6? No, it's not. So I can also give C out n by I. So 36 by 1, what do you get? 36. So if you see, we got this one, 1 cross 36. We got the 1, we got the 36. Now, we go again. We continue the for loop. Now, we are present at 2. So, is 36 mod 2. 36, of course, yes, it's divisible by 2. So, I am printing 2. And then I am checking again. If I is not equal to root 10. Is 2 equal to 6? No, it's not. So 36 divided by 2 is what? It is 18. 36 divided by 2 is what I am doing. It is 18. Okay, so this again gets displayed. You see, this is 2 cross 18 that we got. Now, third iteration I. 3. Is 36 divisible by 3 first? Yes, of course it's divisible. So CO3. If I is not equal to root 10, if 3 is not equal to 6, what will happen? I proceed further and then I'll display n by I, that is 36 divided by 3. So what is 36 divided by 3? It is 12. So if you see, we got this 3 cross 12. 3 cross 12 from here. And similarly 4. 4 is, yes, so again 36 mod 4, yes, of course, yes, it's divisible. So we'll display 4. Is I not equal to root 10? 4 is not equal to 6, right? So we have 36 divided by 4. So 36 divided by 4 is what? 9. You see, you got this. So lastly is 5. 36 divided by 5. 36 mod 5. Is it 0? No, it's not. So we don't display anything. So we don't go into this only. We go into the next iteration. Okay. So at I is equal to 6. What happens? Is n mod I equal to 0? 36 mod 6. Yes, of course. So you display 6. And is I not, if I is not equal to root 10, I is same. So you don't go for this, okay, because if at all you don't give this condition, you will get 2 6 actually. It will again go and it will also give you n by I, which is again a 6 right here. So it's only to avoid the repetition that we have given this condition if I is not equal to root 10. So this is going to be your final code, okay, to find the factors of a number. I hope this is clear. So this concludes it. If at all you want to sort whatever you want, right, you can do something like this. Instead of printing things here, you can start to store it in a vector and then sort the vector at the end. Okay, it's kind of simple actually. So you can, what I mean to tell is that you can have some vector of int ARR, okay, and instead of cout I, you can tell ARR dot push of I, okay, and instead of I'm putting this as star, okay, this is star, and let this be dot, okay. So and instead of this dot I can give ARR dot push of n by I. So everything gets pushed in this array and my array is going to look like this. And finally I can simply sort it using sort of ARR dot begin comma ARR dot end. So this is going to sort things completely and my output. So and if at all I give cout return this array, my output is simply going to be what? sorted part. It's 1, 2, 3, 4, 6 and 12, 18 and 36. This shall be my output, a sorted form. Okay, so anything, it depends on the problem statement that you get. Okay, so let's move on to the next question. See you in the next session.